Okay, so the next unit that we're now covering in Unit 5 is going to be continuous and discrete domains. So all that you need to know for this video is you'll have to know the difference between a discrete and a continuous domain. So we'll go over the definition, and then we'll go over a couple examples of it for you to be able to see and determine the difference between discrete and continuous. All right, so first, what is a discrete domain and what is a continuous domain? Well, a discrete domain is a set of input values that consists of only certain numbers in an interval. And it says from here, example, integers from 1 to 5. So what we can think about discrete is we can think about them being counting, like counting numbers. So if you think about our natural numbers, 0, 1, 2, 3, 4, 5, all whole numbers, that's usually what we are seeing when we have a discrete domain. It's something that is going to be a finite number of set. But it's something that if you're thinking about a scenario, as we talked about before, if we're talking about how many people do something, well, we can't have a half of a person. We would have to count them as a whole person. So we would have 1, 2, 3, 4, 5, 6, 7, so on. So we can't have percentages or decimals or a portion of that thing. And if we can't, then that means it is a discrete domain. Whereas continuous is a set of input values and consists of all of the numbers in the interval. So from here, if we're going from 1 to 5, we're including everything 1.1, 1.2, 1.3. So we're including every number, no matter what type. It doesn't have to be a whole number from 1 to 5. And if we're thinking about things that we've done before, we can talk about how much of a pizza that we've eaten because we can eat a quarter of a pizza. We can eat an eighth of a slice. So when we're talking about that, that would be continuous because we need to include every single number from that slice 0 to slice 8 if we're eating a whole pie. Whereas if we're talking about a discrete domain, we can't stop and say, okay, well, we're having half of a person, so we're going to have 1.5. No, once we count that first person and we move to the second, then we're at number 2. There's nothing in between that we can count. So with our discrete, we can think of them as our counting, our natural numbers. So it's all the whole numbers. Whereas continuous, it's every single one in between. So it can be a quarter, it can be 1.25. And if you look at our graph here with our discrete graphs, we're only plotting points at our whole numbers 1, 2, 3, 4, 5. There's no number line connecting them, meaning that 1.5 is not a possibility. Where from here, when we're graphing our continuous, we're doing a point on 1 to 5 and drawing a line connecting them because, as we know, every single point on the line can be a solution. So with continuous, I can do 1.75, and that can be part of my domain. All right. So when it's just discrete, we're looking at these situations where we can't actually include a half of something because it doesn't make sense. Whereas when we're talking about continuous, we can. All right. So for discrete, one of the examples we were talking about before is how many people are riding a ride, or maybe how many cars a car manufacturer makes, because they're not going to make a quarter of a car and try to sell that to someone. So with discrete, it must be that it has to be that whole number, and it doesn't make sense to have that 1.5 in between. Um, Whereas our continuous domain, it is including everything in between, where we can talk about how long we swam in a pool for. Well, we can swim for 5 minutes and 2 seconds, 5 minutes and 3 seconds, and things like that. All right, so a discrete domain is going to be a set of finite numbers counting, and it's typically going to be the whole numbers that we have there. And our continuous domain is including every single number in between, and that we can have that half or that quarter. All right, now we're going to go ahead and go through a couple examples, and that'll be it. All right, so the two examples that we have here is the function y equals 15x represents the cost y in dollars of x tickets for a museum. And the other example we have is a cereal bar contains 150 calories. The number c of calories consumed is a function of the number of b bars eaten. So which one of these will be discrete and which one of these will be continuous? Well, when we're looking at our first example and it says the represents the cost of tickets, well, a museum can't sell you a half of a ticket. Yeah, they could give you half off on a ticket and you're paying half the price, but you're still getting that full ticket. So every single ticket that they sell here is a full ticket. They're not going to say, well, how many tickets you sell at the end of the day? And they say, well, we sold 8.5 tickets. It's just not possible. So this one is discrete, all right? Because when we're selling these, we have to sell 0 tickets, 1, 2, 3, and so on. So we're not selling a half of a ticket. Whereas the next one, it says a cereal bar contains 150 calories. So the number of C calories consumed is a function of the number of bars eaten. Well, I can eat a whole bar, or I can take the bar out and eat half of it now and save it later. Or I can maybe take a bite, like, oh, I actually don't like this, and give it to someone else. So since we can eat a portion of the bar, so we can eat a percentage or a decimal of the bar, this is continuous. right? Because we can have one person eat the whole bar, then we can have another person just eat a little portion of it. So we can actually have, if we have 5 bars, we can do any number between 0 and 5, 1.25, we can do, and it works. So it would be a continuous, meaning that every single number in between that 0 and 5 is part of our domain or can be part of our domain. Whereas with discrete, those numbers, if we can only sell 5 tickets, then it's only 0, 1, 2, 3, 4, 5, and we can't do any other number in between. All right, so when we're dealing with our discrete, it's going to be those finite counting cases where continuous is every single thing in between. All right, so now the last thing we're going to do is just graph each of these two examples just to show you the difference between a graph once again. All right, so for this problem here, it says the function y equals fx, same thing that we just did before, represents a cost y dollars and x tickets for a museum. Graph the given function. So I'm not going to graph this. The first thing I'm going to do is I'm just going to go ahead and pick out just a few points for my domain. So I'm just going to go ahead and graph 0, 1, 2, and let's just do 3. All right, so now I'm going to plug them into the equation. So I will then get that y is equal to 15 times 0, which is going to give me 0. Then I'll get y is equal to 15 times 1, which is equal to 15. I'll get y is equal to 15 times 2, which is then going to be 30. And the last one that we're going to graph is y is equal to 15 times 3, which is 45. All right, so now I'm going to have to create my number line. So each of my tick marks on my x axis are going to count by ones since I'm counting by ones here. So I'm just going to label 1, 2, 3, 4, 5. And I'll do -1, -2, -3, -4, and -5. Not that I needed to do those. And then for here, I'm going to count by tens with my y. So 10, 20, 30, 40, 50, 60, and so on. I'm not going to do the rest. But that's what our graph will look like, just so that this way we can plot these points. So I'm going to plot the first one at 0, 0. So here's my first one at my origin, 0, 0. Then at 1, I was 15. So here I'm at 1, and 15 is approximately midway. So there's my 15. At 2, I'm at 30. So here I'm at 2 and 30. And then at my third one, I'm at 45. All right. Now, when we go to graph this, and we need to look and say, okay, is this a discrete or continuous graph? Well, we know that this is discrete because we can't sell a half of a ticket, remember. So when we graph this, we don't draw a line connecting these. This is our graph. Because remember, if I were to draw a line here, you don't draw this, but if I were to draw a line there, I'm saying every single point that falls on that line can be part of our graph. But since we know that this is discrete and we can't have 1.25 tickets or 1.5 tickets sold, we can't draw the line connecting those. So in a discrete graph, our graph is just going to be those individual points because we need to let the reader know and everyone know that these are the only points that can go in our domain. All right, so we can't draw the line connecting them because if we do, we're saying every number in between can also be part of our domain, which we know is not true since we are selling tickets, and tickets can only be sold in whole numbers. All right, so a discrete graph is not going to have a line connecting them when we're dealing with our functions. All right, now there's one more example, and then that's it for this video. All right, so now for this next example, and the last example of this video, same one that we did before, a cereal bar contains 150 calories. The number of C calories consumed is a function of the number of bars eaten, B bars eaten. Graph the given function. So first, we're not dealing with X and Y here. We're dealing with C and we're dealing with B. And since the amount of calories depends on the number of bars eaten, our bars is our input or our independent variable, which means this is our normal typical X. So that means that our B is going to go along our horizontal line, and C is our output, or our dependent variable, which is our typical Y. So that means that our vertical line is going to actually be our C. So just because it's not X and Y, it doesn't mean that we can't still graph those. It's just we have to think about which ones are our dependent versus which ones are our independent, and it just replaces that on our graph. So now I'm going to go ahead and create a table just like I did before. So I'm going to have my B and my C instead though, because that's the variables that we're using here. And I'm just going to graph a few bars as well, 0, 1, and just those three. We'll do one more. 3. Those will be the domains I'm picking. All right. So now, same thing as we did before. Well, this one, they don't give us the example, but we do know that if each bar includes 150 calories, that the amount of calories that we consume is equal to the number of calories of each bar times the number of bars that we consume. So for me to solve these, I just need to plug this into my equation as well. So then I know that C is equal to 150 times 0, which is also going to give me 0. Then I'll say that C is equal to 150 times 1, which is 150. C is equal to 150 times 2, which is then 300. And the last one is C is equal to 150 times 3, which is 450. All right, so same thing as before. I'm going to just go ahead and label these 1, 2, 3, 4, 5. Just so I know what my numbers are counting by. And I'm going to count by 100s because I see that these are separating fairly largely. So I'm going to count by 100s with my Y values. So 100, 200, 300, 400, and 500. All right, so now I'm going to go ahead and plot these points. I have 0, 0. I have 1 and 150, so here's approximately halfway. There's our 1. I got 2 and 300, so there's 300 and there's 2, because it's going up at 2 and over at 300. And then at 3, I have 450, so it'll be approximately right there. Now, when we graph this, we have to think, okay, what type of graph is this one? Is this a continuous or is this a discrete? And we know that this is continuous because I can eat half of a candy bar. So when it's a continuous, I need to draw a line going through these. So I'll draw my line connecting those, and I'm going to have my arrow, meaning I can go to infinity because I didn't limit my domain. And remember, in a graph, it's telling us that every single point that falls on that graph will satisfy this equation. And also work. So since this is continuous and I can eat 1.5 candy bars, I can look and say, okay, well, how many calories do I eat at 1.5? All right, so we need to draw the line for continuous because every single point in between those and beyond will work. All right, so that will then be our graph here. Now, I drew this graph and stopped at 0, 0 and didn't go beyond here, and that you wouldn't do in this example because when we try to go in this direction, our x value will be negative, and we can't eat a negative candy bar, so we would have to stop at that 0, 0, but make sure you're drawing that line. All right, that is it for this video.